specific gravity is 2.68, and the water absorption value of coarse aggregate is 0.5, and the free surface moisture content is nil. And if we talk about the fine aggregate, so the specific gravity of fine aggregate is 2.66, and water absorption value is 1%. The free surface moisture is 2%. Similarly, the chemical admixture specific gravity is 1.1. So next, and the test data for material. So here you can see the sieve analysis of coarse aggregates. So according to sieve size and percentage of coarse aggregate first, coarse aggregate second, the percentage passing of different fractions, like a coarse aggregate 160% and coarse aggregate 240%. So in the combined ratio is equal to 100%. Similarly, the sieve analysis of fine aggregates. So it is conforming to the table number 4 according to Indian Standard 383. So here you can see the table, and the fine aggregates conform to the zone second. Okay, so according to zone second, these are the value of fine aggregate. Similarly, we have all data. So now we will first of all we will calculate the target mean strength. So in the previous lecture I already told you the formula means so by using f dot ck is equal to fck plus 1.65. This is the formula of target mean strength. So fck is 30 and 1.65 into s is the standard deviation. So according to Indian standard 456-2000, we will take value from the that code. Okay, so according to that code, the value of S is 5. So then we will calculate a target mean strength is equal to 38.25 Newton per mm square. And if we calculate the target mean strength according to Indian standard 10262 2019, so the formula is different. F dot ck is equal to fck plus x. So x is a factor we will take from Indian Standard 10262 2019. So according to that formula, our value will be 36.5 Newton per mm square. Then the another thing is selection of water cement ratio. So from table number 2, so the maximum water cement ratio is 0.5. So 0.5 is given to you in the question, and according to based of graph or experience we will adopt 0.45. So 0.45 is less than 0.45. So then we will say is it okay. Then the another thing is means how to select water content. So from the table number 4, according to Indian standard, the water content is equal to 186 liter for 20 aggregates and 25 mm 25 to 50 slump. So but according to our questions, the slump values vary from 50 to 100. So 100 slump correction need to be applied. So increase water content by 6%. So water content for 100 slump so is equal to 186 plus 6 upon 100 into 186. So by using that formula, the water content value is 197.2 liter. So as a super plasticizer is used, so we will reduce 20% and above. In case if we add some super plasticizer, then we will reduce our water quantity 20% of cement. So based on trials, water content reduction of 15% has been achieved. So hence, water cement content is equal to 197.2 into 0.85. So then the value comes 167.6. Okay. Similarly, the calculation of what cement content. So from stroke 4, adopted water cement ratio value is 0.45. So and the water content value we already determined 167.6 liter. So cement is equal to 0.167.6 upon 0.45. That then the value is 372.4 kg per meter cube. So we will check according to table number 2 for moderate condition. So the minimum cement content is 300 according to condition, and our value is 370.4. So our value is more. Okay, then we can say it is okay. Similarly, the calculation of fly ash content. So I already explained while I explaining the steps of grade of concrete. So that time I told you the total cementitious material we will do 30%. We will add as a fly ash 30% of cementitious material. So quantity of fly ash content of total cementitious material is equal to 373 into 30%. So that the value is comes out 112 kg per meter cube. So and we will use OPC. So 373 minus 112. Then the value comes 261 kg per meter cube. Here we can say so the cement value is 261. If we add some fly ash, otherwise the cement value is 373. So we will add some fly ash, means 30% of fly ash as a cementitious material. So the value is 112. Then we will calculate the volume of coarse and fine aggregate content. So from table number 4, 10262 2019, or the fine aggregate June 2nd for water cement ratio 0.50 is equal to 0.62. So 0.62 value we will take from the Indian Standard Code. So as the water cement ratio is lower by 0.50, 0.05, then the proportion of volume coarse aggregate is increased by 0.01. So the volume of coarse aggregate is equal to 0.62 plus 0.01. So therefore, the volume of coarse aggregate is equal to 0.63, and the volume of fine aggregate is equal to 1 minus 0.63 is equal to 0.37. Similarly, the estimation of fine aggregate proportions. So while we will design the grade of concrete, so that time we will take a 1 meter cube volume of concrete. So the volume of entrapped air in the wet course is equal to 0.01 meter cube. The volume of cement 261 divided by 3.1. So 3.15 is a specific gravity of cement into 1 upon 1000. So then the value comes out 0.082 meter cube. Similarly, volume of fly ash. So the quantity of fly ash is 112 divided by 2.2. 2.2 is a specific gravity into 1 upon 1000. Then the value is 0.0509 meter cube. Similarly, volume of water. So the quantity of water we already calculated 167.6 divided by 1. 1 is the specific gravity of water into 1 upon 1000 is equal to 0.168 meter cube. Then the volume of chemical admixtures, so the 3.72, and the specific gravity of chemical admixture is 1.1 into 1 upon 1000. So then the value is 0.0033 meter cube. So if we talk about the volume of all ingredients is equal to 1 minus 0.01 minus, then we will add the whole volume of cement plus volume of fly ash plus volume of water plus volume of chemical admixtures. So then the values comes 0.686 meter cube. So volume of cementitious material of water are obtained by mass of respective material upon 1000. So this is the formula of volume of cementitious material and water obtained. Okay, so So estimation of fly ash proportions, then the mass of coarse aggregate. So coarse aggregate 0.686 into 0.63 into 2.68 is a specific gravity of coarse aggregate and 2000. Then the value comes out 1158 kg. If it, similarly, we can calculate mass of fine aggregates 0.86 into 0.37 into 2.66 into 1000. So the value is comes out 675 kg. Okay. Then another thing is mixed proportions. So we will calculate for 1 meter cube. So cement quantity is 261 kg, and the fly ash we already calculate 112 kg, and the water quantity we already calculate 167 kg, and fine aggregate we already calculate 675 kg, and the coarse aggregate we already calculate 1158 kg, and the chemical admixture, the 1% of total mass of cementitious is equal to 3.72 kg, and the water cement ratio we already adopted 0.45. And so similarly we will calculate the water absorption of coarse aggregate is 0.5, ferry moisture in fine aggregate is 2%. So the extra quantity of water to be added for absorption in case of coarse aggregate at 0.5%. So the 0.5 divided by 100 into the quantity of cement coarse aggregate 1158. So that the value is 5.8 kg. Similarly, extra quantity of water to be added for absorption in case of fine aggregate at 1%. So 1 upon 100 into the quantity of cement as a fine aggregate is 675 is equal to 6.75. Quantity of water will be reduced at by 2%. So the 1%, 2% is already mentioned in the question. So according to question, we will calculate if the free moisture content is not given in the question, then no problem. Then we do not need to calculate water absorptions. Okay. So actual water required 167 plus 5.8 plus 6.75 is minus 13.5. So then the value is 166 kg. Similarly, actual sand required 67 675 minus 6.7 plus 13.50 is equal to 68 682 kg. So the actual coarse aggregate required 1158 minus 5.8 is equal to 1152 kg. So this is the actual value of water, sand, and coarse aggregate. Similarly, the actual quantities of trial number 1, so the cement is 265, fly ash 110, sand 682 kg, coarse aggregate 1152 kg, water uh, water 166 kg per meter cube, and the chemical admixture is 3.72 kg per meter cube. So this is the here you can see the images of some trial mixes. So while we make the concrete, so that time we will check workability with the help of slump apparatus. So this is the method of workability. So by according wall test, they will check the workability, and the for good construction practice, here you can see this is the placing of concrete, the method of placing of concrete. So benefits of good construction practice, here you can see the compaction of concrete, control water cement ratio, superior finishing of slab and wall, no honeycombing, reduce cracks, durability of structures.